Hello, hello, this is Blaster Toad here. For anybody on our Discord, you will have seen that I've been working on a dungeon generator over the last little bit. So, let me just go grab what I've been working on, and this will be the basis of what we'll be building here. I come out here, and I close these off, and I tell it to generate for me. We've got a random dungeon. If I tell it I want a new seed, it'll make us a new one. So new seed and generate, there's a new one. Let's do that again, and there's another different one. And I can tell it how many rooms I want. Then I have to tell it to regenerate. And yeah. It makes some rooms, it makes paths between them, it'll cut out bits of the floor so that the rooms are a little bit more interesting. And I also in Discord said I'm going to give it a week before starting to make the tutorial on how to do this. Well, apparently I'm a sucker for punishment because I'm doing this right away. And then that way it will be out in a week for anybody just publicly viewing it. As always, for Patreon members, you're going to get access to this early. And you also get the project files over on patreon.com. So you can always check out the ToadNet Patreon if you want access to the project files. I will be linking the model files for my tile set here. Just so that you guys can end up with the same result and you've got something to play with. But if you want the full finished project files, those will be available over on Patreon. So, that's that. Let's get started. I'm gonna open up my project there as a baseline of what I want to do. Here is our fresh project in my content example, and we are going to just start with a brand new empty actor. So just go ahead, create yourself an actor, something about generation. I'm calling mine dungeon gen. And then we're going to just start with some variables. So variable 1, we are going to want seed, and seed is going to be an integer. And the nice thing with generating random things off of a seed is if you ever want to save it, you only have to save the seed. You don't have to save the whole map or loop through the static meshes or that have been placed. You just have to grab the seed, which is awesome. We are then going to put that into a category, map settings. We're going to duplicate that. We're going to put in room size underscore min. Duplicate that and do a room size max. We are then going to... I'm just trying to decide what I'm doing, what I'm not doing. So we're just going to do single level dungeons because doing it multi-level doesn't add a lot of complexity here. But when you start building levels to connect it with stairs and all that can become interesting, so we're not going to bother with that. Okay, so we're not bothering with levels. We do want a number of rooms. We're going to duplicate for room count. You're just going to drag that up. So we've got the room count. So how many rooms? Min size. The max size. Duplicate again. Merging. And we're going to set that to a Boolean. So whether or not we allow rooms to butt up into each other. And then we're also going to put in here floor call underscore min, and we're gonna duplicate that floor call underscore max. And what this will do is cut holes in our floors so that it makes the rooms not just big rectangles, gives them a little bit more interesting shapes. Okay. We are then going to also have another Boolean for branching. This is not 100% necessary, okay? But the reason I've put branching into my engine generator is it allows a fallback in case the generator gets stuck. And that way you can do huge things. I've had the basic version of this generate 20,000 rooms. It takes a while, but it will do it. So then after branching, we want to duplicate that, and we want branching threshold. And this will be another integer. Okay, and then duplicate branching chance. So once it reaches the threshold, how likely is it to branch? We are going to make that a float. And then duplicate, we want max loops. And that will be an integer. And that one we're going to put under category editor tools. Okay. We're going to duplicate our max loops, and we're going to have a new seed, and that will be a Boolean. And then we're going to do another variable, and this one will be random, or we'll just call it stream. It is a random stream, and that's what we're going to set it as in variable type. Stream, random stream, right there. I'm just gonna check the recording. Recording seems to be going fine. Okay, so we've got a bunch of variables here. We're now gonna go to the construction script, and I'm gonna do a sequence. Okay. And on the construction script, we're going to do 3 things, I believe. Yes, 3 things. Okay. So, if we press new seed, we are going, so if new seed is true, we're going to branch, and we're going to set it to false. Okay. And what I do here is, this way I will have a button in the editor where I can just press this variable. It will be set to false immediately, but it will do the thing. So it acts as a nice little button press. So we're gonna make all of these variables that we just made, except for stream, visible. And there we go. Okay. We're then going to set seed. So I dragged it out and held Alt to get a set node. And then I want a random integer. This is going to be our only random integer that is not using the stream. And then this here, 900,000. Sure, 900,000 will be our max seed. 0 to 900,000 gives us lots of different permutations. And then we're going to get our stream, pull off, and set seed, set random stream seed, just like that. And we're going to plug that in there. Okay. Next thing we're going to do, we're going to copy this bit, place it down here, and just plug the seed right in. So this one here, we're going to comment and say manually update stream with seed. this top line, and I'm just going to turn off bubbles on that. This top line will be on, and I'm hitting C to get the comment box. On, click, new seed, get new random seed. So what this is doing is when we click new seed, it will get a new random seed and it will set it. This one here is if we change the seed, it will update it. And because it's running on the construction script, as soon as anything is changed, it'll do this. We don't have to do anything else there. We're now going to go over to our event graph, get rid of all of this. We're going to make a new custom event, and we are going to call this generate map. Okay. So when we generate the map, we need to do this for every room. So we're going to do a for loop. We're going to get room count -1 because our count here will start at 0. And I'm just hitting Q to automatically straighten things that I select. Okay. We're going to check if this is equal to 0. We're then going to run a branch. And then we are going to make a room. So we're going to do a new function. And we're going to call this one, I like to group my functions by name, so we're going to room underscore make floor area. Okay. And then on our make floor area, we want an input. The input will be location, and that will be of type int vector. So vector, but instead of floats, it's integers. So we're going to base everything off of. So that means one more thing we need in here. So under editor tools, we're going to make another variable, and we're going to call this scale. And that will be a float. Okay. So right off the bat, we're going to save this location. So we're going to promote this to a local variable. And we want that to be called root location. So this is where our room starts generating from. We are then going to need an X and a Y value. So we're going to get our minimum room size. We're going to get our maximum room size. Dragging out and holding control, I get the getter on those. We then want random int in range from stream, right there. And we're going to be doing this twice. Doing this twice is not 100% necessary. I'm going to say that a few times throughout this, because a lot of what I do here is not necessarily needed for our outcome. But the reason why I do 2 of these here is that I find the random integers tend to spool upward in Unreal Engine. For whatever reason, they seem to cluster at higher numbers. And if I get this, and then so I pull off it once and pull off the same node again, I'm going to get values that seem pretty close to each other that are clustered together. So a lot of times when I do that, I would end up with very square looking rooms. But I find if I do two different ones, then I get a greater divergence. So I get a greater likelihood of them being rectangular rooms or square rooms or long but thin rooms or really short but fat rooms. It seems to, it may be all in my mind, but it seems to give me a better variation. So that's why I'm doing it this way. And then off each of these, we're going to promote to a local variable. And we're going to call this out_x. And same here, promote to local variable, out_y. And we've got X and Y locations. Awesome. We then need one more variable out here. We want loop count. Actually, we can do that as a local. So we'll do a nothing here. We need another local variable. We're going to call this one working. Oops. Let's fix spelling on that. Working. It will be a Boolean. I'll pull this out here. And we're going to do a while loop. So as long as we're telling it it's working, it's going to keep looping through this. Okay. Now we are going to get our out x and out y. We are going to multiply them by each other to get the area. We are going to -1, so we don't get an additional. I'm going to hit Q to straighten that out, move the y down, move that one in. And then off here, we want a for loop. Right, like that. Then off our for loop, that index, we are going to divide it. And then modulo. I don't know exactly what the hell modulo does, but I know it works for this. And then we want to put our y into both of those. Okay. We then want to add. And what are we adding in? We are adding in our root locations. I'm going to get the root location, break the int vector, and put that in there. And then we're going to make int vector, and we're going to plug those in. We're adding this to the root location, just like that. Okay. We then need to make a new variable. So we're going to right click on root location and duplicate. And we are going to call this tiles. And we're going to make it an array. We're going to get tiles and we're going to add. Straighten that off. There we go. Okay. Then when we're done working, so we're actually going to off complete here. We're going to set working to false. We want to set working's default value to true. And like right now, this does nothing, so we could have it just like that. However, we're going to be making use of it here in a moment. Then we are going to duplicate our tiles. And we want to call this connected tiles. Actually, our while loop could happen after this, yeah. That's what we'll do. We're gonna move that down. Okay. We're just gonna do that so it just invalidates itself there. Okay. And this here section, we're gonna comment get random x and y extents and to make array of floor tiles from x, y added to root position. There we go. So that's what that's doing. Okay. Then, when our while loop is done, which will be immediately in this case, we want to get connected tiles, which we're just going to set. So we're going to set connected tiles right here, just to test our first bit. And then on our connected tiles, we want to, for each loop, we then want to break int vector. And we want 2 integer arrays. We'll get duplicate and we'll call this extents underscore x, and that'll be an array. And then duplicate extents underscore y. And we're gonna get extents and add x to it. And then we're gonna do the same thing for y. Now what we're doing here is, because in a moment we are going to have, so right now, the biggest numbers in x and y, so the furthest extent from the root, is going to equal these x and y's. But in a while, we're going to be modifying that. So after we've modified that number, we need to see which one is the biggest so we can see how big our room actually is. So that's why we're doing this. We're getting extents x and y. Then there is a nice little thing. So if we then pull these out, we can then get max of int array. And we'll get the max of both. Okay. I'm just gonna go back and check something. Yes, okay. I made mine more complicated than this, but then I didn't connect some of it up. So yeah, we just want the max values. We want to make int vector, and we want the max x and the max y. We don't care about z because we're going to be getting that from the root location. We also want our connected tiles. And we also want our root location. There we go. And then we are going to find our beginning. We're going to add an output. This will be floor tiles, which will be an array. We then also want single vector root location. Oh, we'll just put location. It won't let me use either, okay? Because I have both named there. We're gonna cheat it, and I'm gonna say location with a space. Ah, eat that, I can do things. And then we want one more there on our output. And that last one will be extents. Okay, so connected tiles goes in floor tiles, root location in location, extents is that. And there we go. Okay. So now we're going to go back to our event graph, and for loop equals 0, we want to make a floor area. And the location we're going to promote to a variable. Call this previous location. And then we are going to need a couple more variables. We're going to duplicate that previous location. We want floor tiles, which will be a array. I'm going to pull out here, and on the first one, we are going to set it. That will change for subsequent ones. And location is the same as this. So I could forego that pin and just go straight like that. However, I like to keep everything flowing in a line from one to the other. Why is this not saying extents yet? There we go. Just had to compile, save, and then refresh. There we go. Then we then want to copy floor tiles. So we're going to duplicate that, and we're going to call this rooms. And this will be a map. So this down here. And side 1 will be an int vector, and side 2 will be an int vector. And what this is doing is it's going to save the location of our room and the extents of our room that we can just pull up in a single go pretty much. And we're going to use this later as reference to build our corridors. I'm not sure it's going to be in this video or whether that's going to be its own video, because the corridors are a pain in the ass. Okay, so and there we go. So we make our first room, compile and save. Now, if we set our seed to anything, I'm going to have default value 100. Room count, we're going to want 1. Minimum room size, 3 tiles. Maximum room size, let's go with 15 tiles. So we can see some big differences. And when this is complete, we then want to do a new function. And we want this to be spawn tiles. And there we go. And we're going to do a for each, not fro each, for each loop. And for right now, we're just going to be getting floor tiles. We are going to change this to a vector. We are going to multiply that vector by a float, which is our scale. And this will just be the size of your tiles. And then we need to do something. So we could spawn a static mesh or add a static mesh or spawn a blueprint, but what we're going to use that doesn't melt your computer is instance static meshes. We want an instance static mesh. The difference between the instance and the hierarchy, that word up there, actually, just in case you can't see it on the video, so we've got instanced and hierarchical instance static mesh, whatever. The difference being that the hierarchical ones, I'm just butchering that word and I know it. They allow you to have loads. So LODs, levels of detail. So if you had very complex meshes, that's a good idea. My tile meshes are very simple, so I'm just gonna go ahead and use the instance static mesh. And on our loop body, for every floor tile, we are then going to get the instance static mesh, which I'm going to rename to floor. And I'm going to add instance. And I'm going to split out that struct pin just like that. So we're going to go back to our event graph. So once this is done, once that's all complete, we're going to come down. Now we are going to spawn tile. Okay. And on our construction script, we are going to generate map. So whenever we make a change, it will show up. So now if we go to our viewport, and we compile and save, nothing happens because we have no mesh. And my scale is 0. So I'm going to set my scale to 200 because I'm going to go import my meshes. So I'm going to do new folder, mesh. And I'm going to grab my corner, door, floor, outer corner, and wall meshes. And I want to bring them all in at -90 rotation. I'm going to take a second to grab my shaders. Then for the corner pieces, I want to come down to import settings, transform, and I want to set those back to 0. Yes, that's what I want to do for both the corner pieces. So for the outer corner and the inner corner here, I want to set their import value to 0. And that's just getting the rotation on my meshes. Okay, so I'm gonna save. This should be 200 by 200. Yep, perfect. We go back to our dungeon generator, and floor, we're going to select in our static mesh. I'm going to select floor. And look at that, it is giving us a randomly sized floor between 3 tiles wide and 15 tiles wide. So let's change that from like 3 to 5. Look at that. And then if I go and I click new seed, it's going to keep giving me different ones within those values. Yeah. Perfect. Now we just need to do that tens to hundreds to thousands of more times. So let's go back to our event graph. We are now going to do another new function. And this is room underscore find next location. Okay. Find new location. There we go. So I want to have a new array. So I want a new local variable. And this will be called directions. And this will be an array of integers. And we're going to set directions. And then we are going to pull off here and make an array. And we want 8 pins in here, so it should go up to 7. And we want 0, 1, 2, and so on and so forth. Because what this is going to give us is a reference point that we can, for each of these numbers, try looking in a different direction for our next room. And if we can't find it there, we can remove that number from the list so we don't look for it again. Then we're going to have a new local variable. I'm going to call this searching because it's searching for a new room location. I could call this working as well, but whichever. We just need some Boolean that is default true that goes into a while loop. Okay. And while loop, we're going to get directions. We're going to get last index. I'm going to make sure that is greater than or equal to 0. So there's at least one option left. And branch. And it's going to put these ones together here so that they're easier to comment. Make sure any options, or make sure options available and And if that is greater, then I want to do a new variable, test index, which will be a integer. We don't want to get it yet. We want to set test index. And we want to, from our last index here, do a random integer from stream. That'll get us 0 to the last index number. Our stream, we're going to plug in our stream. And then that's going to go into our test index. We're randomly getting a direction to try. Then we need to test our current location versus our blah, 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 and the rest of it. Yes. Okay. So we are going to make a new macro. Go macro. We're going to say test relative tile location. So we want to make int vector. Now we want a break int vector as well. The break will go in here, and this will be our reference location. Okay. We then want a plus on our X and a plus on our Y. We are not doing anything with Z, so we don't need to plug that in. Just go like that. Okay. Then we are going to, I made that needlessly complex over there, did I? Yes, so just gonna plug this in. Now we're gonna have it X. And plug this one in. Have it Y. And then we are going to check if this relative location. So basically what we're getting is we're getting a location. And we're going to say, okay, is 1 forward in here? Is 2 forward in here? Is 1 forward and 1 to the side in here? And then we're going to check that against our floor tiles. We're gonna output location and is floor tile. Something like that. Straighten connection to our output and then straighten that. We can drop that down there. And there we go. Check if tile relative relative to reference is in floor tile array. Okie doke. So, file save. We are then going to go to our find next location. We're then going to pull out our test relative location. And our reference is going to be the previous location, the previous room location. And then we need to make 8 of these. That's 4, perfect. I'm going to just grab all those and paste in 4 more. Okay. And then I can grab all those, hit Q, and it will straighten all those little pins up. Nice. We're then going to get our test index and do a select. And we're going to plug in each of these as one of the options. And again, we need 8 options, so 1 through 7. Okay, so there is our test locations. We also need our test results. So we're actually going to move that down. Control C, Control V, put that up here, and then, oh, it's not going to let me do that. Okay, so I need a new select. Select, and again, 7, 8 options, and then here I'm gonna put in floor tile. Just like that. Okay. So what this is giving is whether the location we're testing for already exists and what that location actually is. So then we need to give it references. What we want here is our max room size. And this is where things get interesting. So we want to check if there is space forward of us. So actually, let's just quickly open up Paint. What we're doing is we've got our room right there. Okay. So this is our last room. We are then going to check, is there a room this way? Which will be an X check. Is there a room this way? Which will be a Y check. All right? And then is there a room this way, which will be a negative y check. And if we just did the 4 directions, we would only need 4 values. But because I don't like making things easy on myself, I also have, is it over here, which would be an X and a Y check. So we can get diagonal rooms. And these are what we're setting up. So we're going to check if it's forward. And we're going to check against max room size. But what we're going to do here is we're going to get our max room size. We are then going to get merging. We're going to branch. Or no, we want to select. Okay. And if merging is allowed, we just want room size. So this means 2 rooms could butt up against each other. If merging is not allowed, we just want to add 1 to our check, so it always keeps the rooms at least 1 tile away from each other. And we're going to straighten those off. And that will go in our X. Okay, so that is checking for forward location. We then want to check for forward and right. We then want to check for just right. Then we want to check for rear right, so we'll need our room location times -1, give us the inverse, to give us backwards, so backwards and right, or just backwards, or backwards and left, or just left, or forward and left. So that gives us our 8 directions. Yay! We're then going to run a branch here. So, is this already a floor tile? If it is, we want to get our directions, remove index. And we're going to remove our test index. So that way, because while we have it set to searching, it's going to continue doing this. So it's going to remove that option so that on the next run, it is not looking through something or possibly checking something else that it's already checked. So that's why we're doing that here. And then we're going to set searching to true. It says, hey, keep on searching. However, if it is not already a floor tile, we're going to say, hey, look at this. We've got a new location. We're going to set searching to false because we have now found something. We are no longer searching for it. And we are going to do another new variable, duplicate. We're going to say valid. This is a valid location. We want to set valid to true. And we want to make sure valid is false by default. And then we want to set new location, which will be an int vector. And there we go. Okay. So that will find our next location. If last index, so if we do not have any more options, so if our make sure options are available is false, we want to set searching to false. We want to stop searching because it can never get a value now. And we want to set valid to false. Fail out and flag invalid. Because otherwise you can get an infinite loop happening here if you've done a bunch of rooms and all of a sudden it's like it is worked itself into a corner where there are no other options for it to move to. Then from searching, we need to output, so we're going to do a new output. We want new location. And we want to tell whether or not that is valid. And I'm going to move valid up in that list, make it a Boolean. And then we're just going to output this here. Is it valid? If so, set the new location. Compile and save. Okay. So, event graph. We now, if this is false and it is not the first room, we want to room find new location. If this is valid, so we want to branch. Then we want to copy this, Control C, Control V, make our new room at the new location. We're also going to save this location, so we're going to promote to variable, new location. Why I can't use it because I'm using that name elsewhere. Okay. We'll call it next location. And there we go. Oh, we've already got it being set up. So we're gonna set next location and plug that into our make floor area. We do not want to set the floor tiles though. We want to get our floor tiles and append array. We'll straighten that off. Straighten that off. And move rooms down a bit. And there we go. Then when all that is done, we want to set previous location to the next location. And we're going to do something in between here with when we get to doing the corridors. But right now we just need to set it up like that. Okay. So now, compile and save. We should be able to say, hey, I want my room count to be 5. Ooh, look at that. I now have 1, 2, 3, 4, 5 rooms. Awesome. And if I say I want them to have a minimum size of 2, but a maximum size of 10, see, we get some bigger variations. And I'm going to hit new seed a couple times and see how they... I'm gonna zoom out here because we'll see how they jump around now. See, we get a bunch of different setups. But they're all rectangles. And rectangles are boring. So let's go make them not rectangles. Okay. So we need to go to make floor area. Yes, make floor area. And now we're going to work off this area here. So first, this here, we are going to comment this section. And we're going to comment this to get outer extents of room. And output final results. Okay. And that can come over here. Don't want it getting in the way. But over here where we're going to be working, whoa, this is where it's going to get interesting. So, first thing we can do is let's make a new variable. Duplicate our floor column in, and we'll call this floor culling ? And we're going to make that a Boolean. No, Google, I don't need you right now. But I don't need you. Go away. So get floor culling, we are going to branch. And if floor culling is true, we will do this. However, if floor culling is false, we're going to just go straight do this. So that way we can bypass this whole thing. Mine checks if there's other information here, but it's a lot cleaner to actually just bypass it if we don't need it. Okay. So now to do something with floors. Okay. So we want to do a new local variable. And we're going to duplicate this and we're going to call this tiles copy. And we're going to set tile copy from tiles. Then we are going to do a for loop. And we're going to get a random value. So we want a random int in range from stream. You want this -1. We also want to clamp this to tiles copy length. So how many are there? Divided by, and I'm going to say 4. So it can only ever call up to a maximum of 1/4 of the tiles in that room. Okay, our minimum will be our floor call min. Our max will be our floor call max. Go figure how that works, eh? Then of course, stream goes in stream. And then this final clamped value goes in our for loop. We're just gonna move this all a little bit further down to make it nice and pretty look. And this one here, I'm manually straightening instead of using the automatic, because if I have that many tiles or that many nodes in a row, then it can sometimes do funny things when it goes to straighten them. Like it would drop this one down to try to make this all straight and things like that. Okay. We've got our culled tiles. We are then going to get our tiles copy. We're going to get last index. We're going to get a random int from that. Random int random int from stream. And our max will be the last index. And of course we want our stream. Okay. And then we just want to remove that. So we're going to remove index. Cool. There we go, and we're now dropping pieces out of our floor. When that is done, we'll set working defaults, and we're going to set connected tiles to tiles copy. No, we're not done here. This is just to show us why we need to do, or to show you why we need to do more. If we hit compile and we hit save, then if we go over to our viewport, and floor culling, we're not going to turn on yet because we want some values first. So minimum floor cull 1. Maximum floor cull 15. So maximum 15 tiles can be dropped if that's under a quarter of the number of things there. And then if I turn on floor culling, look at that. Things start to look a lot more interesting. So we start getting bits dropped out here, so that'd be like columns in a room. We've got some columns and corners over there. Merging, do we have merging on? No, so we want merging on. And then we get really interesting results. So these two rooms, so let's just turn merging off again. Let's see how these are separate. Turn merging on. They come together to make one big room with a bunch of cutouts in the middle. So now if we go to our room count and say we want something more like 20, and all of a sudden we're getting some very interesting results, where we have rooms with dead ends, L-shaped rooms that have merged together with different view blocking columns in them. And I'm saying these holes are columns because walls will be drawn around them at the end of this. So it'll make basically a column there in the middle of the room. But yeah, we start getting a lot more interesting results. However, if we don't even need to iterate through this any more times. If we look at a room like this, well, we've got this one sad little block right here that's just touching on its corner. It's like barely holding on to its friend there, but there would be no way to walk from block to block to block. And we need to get rid of him. Okay, so sad little guys, we aren't going to move around. We're just going to say, nope, GTFO, get the hell out of here. So let's go back to our make floor tiles, and now, after our for loop, we are going to make sure everything is connected. Huzzah. Okay. So, we are going to then get our connected tiles and clear connected tile. Because this can happen a few times here, we need to make sure it's cleaned every time we go through the loop. So this bit here, we're going to comment real quick. Randomly remove tiles from floor. Okay. Move this away. So after we've cleared the connected array, we then want to add an item to it. So we've got a starting point. And our starting point is going to be tiles copy, get a copy of 0. Okay, so it just gives us something to start from. I am then going to do a while loop. And we're going to make a new local variable, tile found. Because what this is going to do is for every tile that's connected, every tile in the connected array, we're going to go through and check the copy or the tiles array and see if it has any neighbors. And if it does, add it to the group. We want tiles found. We're going to set that to false right away. Of course, it has to be true to begin with. And then we're going to do a for each loop. And we're going to get our connected tiles. And then we are going to go and change our test relative tile location. And we're going to pull this out. We're going to move that up in the stack. And we're going to call this test array. That means we have to now go back to our find next room and plug in a test array, which will be floor tiles. But it also means that we're going to be able to reuse this macro in more places and make things a lot cleaner in a lot of other spots. There we go, compile and save. Oh. Don't freeze up on me. Come on. Come on back. See, this is the problem with having everything hooked up to your construction script, is you go to change something like this, and then it has to regenerate everything. And if it runs into a problem, well, then it can freeze and hang up, and you just gotta wait for it till it putters itself out, and it's like, oh, that's an infinite loop. I'm gonna stop doing things now. Yep, somewhere I've got an infinite loop. It's probably in here, because we're telling it to stop. Oh, there we go. So room count, we're going to set the room count from 20 to 5. So that it has a real hard time getting stuck on things. Okay, maybe we just have a bad seed, because... Oh, come on. Yeah, it's getting stuck on something, and it shouldn't try to just generate 5 rooms. We're going to go to our construction script, and we're going to unhook our generate map right now. Oh, you know what it is? Because I'm working in the make room here, I'm never telling it to stop working. Haha. See? never telling it to stop. So that's the problem right now. Okay, so for each connected tile, we are going to test relative room tile from this location, and our test array is going to be our tiles copy. And the good thing for this here is that we only need to do this in 4 directions, because we're not counting angled ones as connected. We only want things connected in the 4 cardinal directions. So we want forward 1, we want right 1, we want behind, so -1 on the X, and we want left, so -1 on the Y. Beautiful. And we're going to do a for loop. Straighten that off, move these down because they're interfering there. So our for loop is going to be for 3 items, so 0 to 3, giving us 4 options. We then want to do a select here, and copy that and make another select, same as we did for finding room location. And we want to get our hit, or yeah, whether or not it is a existing tile, which I should change this output to location exists in, oh, that's not how you spell exists at all, is it? Is in array. There we go. Because now it's not always going against floor tiles, it's now checking any array we put it in, so yeah. They're going to do the same thing, have our outputs for our locations. Doop-a-doop-a-doop-a-doop. They all go in there. We are then going to branch. Just so you're aware, because of this macro that I thought of while doing this tutorial, it looks so much cleaner than my setup. Like, so much cleaner. Especially when we get into spawning room, or spawning the walls and corners and stuff like that, it's gonna look so much better. Yeah. So, if that exists, we are going to add it to the connected tiles array. You want to get a connected tiles, add. This output. And then we want to get tiles copy. And remove item. And remove it from there. And then we're going to set tile found to true. Okay. So again, what this is doing is checking each tile to see if it has any neighbors in the list of all the tiles. And if it does have neighbors, it adds it to the group of connected tiles. So they're the array of connected tiles. Okay. What we're going to do here, comment this, loop through tiles, testing if adjacent tiles are present. If so, add to connected tile array. There we go. Beautiful. Then we are going to, once all the tiles are found, we're going to come down here and we're going to do a branch. And we're going to check if connected tiles length is greater than the minimum viable area. So minimum room size times minimum room size. You get that area. And all of you people that scoffed at math class, it's like, when am I ever going to use that? Well, if you're doing game programming, a lot. Okay. Especially for anything that's a procedural generation, you're going to use a lot of math. Okay. So, is that true? If yes, then we are going to set working to false. So it stops looping through up here. So it stops doing this and it will come down here through our connected floor tiles and do that. Beautiful. We don't need that anymore. However, if it is not our minimum area, we're going to set working to true. So it continues working. And then we're going to get our loop count. Do I have loop count? Did I not make loop count? I have not made loop count yet. Ooh. So we want a local variable, loop count, which is an integer. And we're going to get loop count. And then we're going to increment it. So you could do a +1 and then set loop count again, but this increment node does the same thing. So then what we want to do here is when we start everything here. So, well, let's just comment this first. Is array of connected tiles larger than minimum area? If not, try again and increment loop count. Because what you can run into is, especially with bigger generations, is that it will keep giving you rooms of size 1. And eventually that'll just bog down the system. So what we need to do is, before we do anything, when we go to working, we're going to check is loop count less than or equal to max loops. And then we're going to branch. And we're going to do this, and we're going to say continue looping while verifying floor and loop count less than max. Okay. That's all happening. So if that is false, we want to set working. Oh, not get. We want to set working to false. And we want to set connected tiles to tiles. Fail out without culling tiles. So this way, if it reaches so many times, it's just going to give up. I find if you want to have massive numbers, max loops should be in around something like 10 tries. However, if you aren't looking for massive dungeons, and I'm talking on a scale of like thousands of rooms, then this can be higher. Like if we set it to 100 right now and kept our room under 100, then we should be fine. What is it doing? If I break this link, and I do that, that's an int vector, yeah. No input for test relative location. Oh, I haven't actually set the location on these ones. So this is on our floor function, culling, making sure there are connected tiles. I just had to put our connected tile location into each of those relative test locations. And now it likes me. Beautiful. So now I should no longer have an infinite loop problem. So if I hook up generate map, it shouldn't freeze. I'm gonna come out here, compile. Yay! We have a map, and we should never see. We're gonna put our room count something bigger. Actually, you know what? For this point, we are now going to bring our dungeon out into the world. And I am going to make this room count larger. So we're gonna zoom way on out. 150. There we go, 150 rooms. Let's have them not merging. And now we're gonna go room from room to see if there are any disconnected tiles. So see here, there's a couple rectangular rooms with no cutouts where it gave up on trying to make cutouts in them. And then because our room minimum size is so low, we get little weird ones like this. So to fix that, I'd bring my minimum room size up to say 4, and then it's gonna regenerate. Yeah. Everything's looking good here. So now, if we try something like 500, it's gonna take a while. But hey, there it goes. We've got 500 rooms. Let go off into the distance there. But we're going to keep this more reasonable at like 20. And then we're going to get a new seed and new seeds and keep getting some new seeds just to see how everything generates here. Yeah, everything seems to be working fine. Beautiful. Okay. So we have made it generate rooms. That's all fine and dandy. We've got it getting new rooms, blah, blah, blah. Right now, we're doing nothing if it fails. Okay. So, what I'm going to do is I'm not actually going to allow branching regularly. We're going to have branching in here. Or you know what? It doesn't take anything to add it, really. So yeah, let's add the branching setup. Okay. So, I'm gonna move this here down. We're going to start commenting stuff. C generate room or first room at 0, 0, 0. Not world location 0, 0, 0, but relative location. So that's the other cool thing with this is it's all relative to your blueprint. If you want to say tack this on to the end of another generated dungeon, you could end up just like adding them together at different points and get something really big, while only saying, instead of saying, oh, hey, generate me a 5,000 room dungeon, you could say, hey, generate me whatever, 100 5-room dungeons. Or, sorry, 150 room dungeons, right? And it's going to take less processing as long as you give it a break in between each one with either a delay or using an async task so it runs on another thread or something like that. Okay. And anywho, and then this here, we are going to find location to place next room and calculate floor tiles for new room. Okay. In between those two, I don't want to edit your text. I want you to move down. There you go. In between those, we're going to do a branch. And we want this off of false. Beauty. And then we want branching. We want our branch to be run off branching. Awesome. Okay. So, we then want to get our rooms. We're going to get the keys. So the keys are the first value. The values are the second value. We get our keys. Last index. And then we're going to say, is that greater than or equal our branching threshold plus actually we could make this a function. Did we make this function? Because where does that come in? No, we're not going to make this a function. So is it greater than the branching threshold plus a new variable, which is last branch. So this way we're making sure that it always goes so many tiles before, or so many rooms before branching again. So it's not just like, hey, I got one room, now I'm gonna go somewhere else and branch off. Because what this is doing is it is going to, oh, and we want an and. And then we're going to get our branching chance. And then we want bool with weight from stream. Then we're going to plug our stream in there. Okay. And then we're going to do a branch. So what this is doing is checking if there's more rooms than our minimum threshold, or our minimum threshold since the last branch happened. And then it's also saying, hey, there's this random chance that I'll branch. Am I going to do that? And it will give us a random yes or no with a weight. So if we set this to 0.5, it has a 50% chance of branching. So there'd be a fair few branches. If you put it to like 0.01, there's going to be very few branches as it only has a 1% chance of happening. So we're going to put this to 0.5 for testing. Then we are going to get rooms again. Get keys. Then we're going to get last index. And then random int from stream. And then we are going to get a copy of that. And then we are going to set previous location. And we are going to set last branch off our last index. So we're not setting where it branched from, we're setting when it branched for how many rooms existed. Okay, so what this is doing is a few things actually. So it's again checking whether or not it should branch, and I just went over that. And then over here, it is getting one of the previously created rooms and setting it as our new, or as the previous location. So then when we come in to find room and we're going off previous location here, we're now going off a room that's already been made. So instead of going linearly forward, the dungeon always marching forward, it now has a chance to go back to a previous room and start making a branch off in that direction, or off of that room in a new direction. Okay? And the reason why I initially made this was so that if our room fails to be found, it will come in here and it will force it to branch to a new room. So here we'll add if no valid room locations, force branch off previous room. Okay. And then here, can and will room branch from previous room. And then this here. Get a previous room to branch from. And then when that is done, we then plug that back in here. It'll either bypass this if branching isn't allowed, or it'll force a branch if there's no valids, but it'll always go to making the next room. Ugh. Yay, procedural generation. How are we doing for time? We are almost at 2 hours. We're 1 hour and 40 minutes. Okay. So, I think we are going to set up walls. We'll have it spawn walls. And then I will do the corridor video as a second part to this. So this will be part 1, and then we'll do corridors in part 2. Because corridors are pretty much just as much or more than this to generate the corridors. So, I'm going to go to spawn tiles. Okay. And then we're going to make a sequence. So, first step in the sequence, for every floor tile, it's going to add an instance to floor. Easy, right? For the second part of that, we are going to make walls. So we're gonna get a sequence. We are then going to make that sequence 4 long. And then we want test relative tile location. Handy little macro. Okay. So we want to see if it contains floor tiles. And location will be this array element. And we're going to double click there to get a reroute node. And then we're going to do a not. We want to check if it is not in that array instead of checking if it is in that array. And we're going to branch. Instead of doing this on a sequence, I could do it on a for loop. For loop's actually going to be cleaner, so let's do that way. For loop with 3 as its last index. Then we're going to select do we actually care about the location coming out of it? No, we don't. Cool. So all we're checking for is whether or not it is in this array. We're gonna Control-C, Control-V, copy that a couple times. And again, we want our 4 directions. So forward, right, backwards, and left. And then we're going to plug these into these options. Straighten and straighten. And we'll straighten that one off too. There we go. Okay, so we're testing our 4 directions. So does this direction not have another piece of floor? If there is not another piece of floor in that direction, we want to make a wall. Okay. So we are going to make a wall. So we're going to add instance, but not to floor. We need a new, we're going to duplicate, and we're going to call this walls, or a new instance static mesh. Oh, did I make this? Damn it. Sorry, I've been doing reduced screen size for a long time in this tutorial. Sorry about that, guys. Yeah, we want another instance static mesh for walls. We're going to plug that into our add instance here. We're going to split those pins. We want to get the incoming location, make it a vector, multiply it by our scale. There we go. And then that goes into the transform location. We then need rotation. We're going to do another select. So based on which way it's checking, it will need to rotate to different directions. So our rotations will be 0, 90. If it's to the right, we're going to rotate the wall 90 degrees to face the right. If it's behind us, we're going to rotate the wall 180. And if it's to the left, we're going to rotate -90. That should spawn walls. And now for walls, I just need to select my walls. Static mesh wall. I'm going to file, save all, compile, save. What don't you like? Oh, you don't like that I haven't plugged things in. Yeah, that makes sense that you don't like that. And there we go, plugging all those in. I should have done this as a stream instead of a recording, because then people could have called me out for not having the video maximized. Again, so sorry about that. Hopefully the content is well worth it. It is getting you a dungeon generator that people are charging anywhere from $10 to like $40 on the marketplace at no cost. So compile, save. Hey, it likes that. And we don't have walls. Why do we not have walls? We go back to our spawn tiles. The for loop, it goes through and it checks. Okay, is option 1 in floor tiles not? Okay, and then it spawns it at there. Why, oh why are you not doing things nice? Oh, because I'm an idiot. I put it into scale. We don't need scales, we need rotations. I plugged it into the wrong thing, and it didn't like it. Okay, so 0, 90, 180, and negative 90. Compile and save, and we kind of sort of have walls. Our walls are weird. Why are all walls weird? So option 0 is ahead of us. Actually, let's see which way it's causing issues. So, I want to go out to editor. So, X is this way. Y. Why, oh why are you doing funny things to me? Spawning tiles at the location of the incoming tile. And we're testing against those. So if it's right, it should be 90. If is my wall imported at the wrong... So X is this direction. So yes, my wall is rotated wrong. Do I have to set it to 0? Ah, so yes, I also have to set my wall to 0 on the import rotation. And now, look at that! When I import things correctly, my walls work. They're kind of ugly here at the corners because it's not spawning my nice corner pieces. But we've got a floor with walls. Across multiple rooms. If there's a hole in the center, it makes a column there. And then we get interesting little cutouts and that in the rooms. Yeah. And there we go. In the next video, we'll set up corridors and we'll get the corner pieces and the doors spawning in as well. Well, actually, you know what? Let's get all the aesthetic pieces spawning because it's actually fairly simple, and we'll leave the next video solely for doing the other thing. Whatever I said it was. Corridors, that's it. Okay, so we're gonna select this whole thing. I'm gonna right click, and do I need to collapse to nodes? Actually, you know what? This is so clean now. I don't need to collapse it to nodes, so I'm just gonna move it down and over some. Gonna comment it. And spawn walls. There we go. Okay. Now let's do inner corners. Oh. So I just want to copy this. Paste it. Spawn inner corners. We're gonna come off our sequence. There we go. And our inner corners, we want 1, -1, We then want 1 and 1. Because this is checking for diagonals. We then want -1 and 1. And then -1 and negative. There we go. And for those, we're keeping the same rotations. Cool. So then we're just going to duplicate, and we're going to call this, was this inner corner or outer corner? I think this is outer corners. Inner corners. And I'm pretty sure this is, yeah, this is outer corners. I have it named wrong in my other project. Outer corners. Okay. So this does need some more checking. So we've got it checking some things right now, but the problem with this is that, oh, right, I didn't change this. So we want that to be corner. Out corner. There we go. Outer corner is outer corner, yes. Why is it just making a bunch of extra walls for me? Because I never set it to... Okay, so if we go to spawn tiles, when I want to spawn the outer corners, I need to actually tell it to spawn corners instead of walls. That might help. So now if I compile, save, they have the wrong rotation. So what do I need to rotate them as? That has to be rotated that way, so -90, I think. That's X, so yeah. Y is... Yeah, that should do it. The things I said that you had to rotate are the ones that you don't have to rotate? Yep, that's how it is. Okay. So yeah, now we've got outer corner pieces. Yay! But you'll notice that it's spawned all the way along the wall too. Because, hey, all those diagonals are empty. So what we want to do is we want to check if there's neighbors. So we're going to go back to our spawn tiles. So we're going to check the inner corner that, oh, this is forward and left. Wait, why did I choose to do forward left first instead of forward right? Oh well, whatever. If I would have had this forward right instead, the rotation should have been correct, but that's fine. We're going forward left, forward right, reverse left. But then we want to check. We're gonna Control C. Oh, not that whole thing. Not that either. Get my hands in the right place on the keyboard. Okay. So we're checking forward and left. So we want to then check if just left. We want 0, -1. And Control C and Control V. And 0, 1. Yeah. So you want to do an AND Boolean. And then we want to do another AND Boolean, I think. So what this should do is give us, okay, it's checking if it's forward and left, and it doesn't have two neighbors. So we want forward and left, and not two neighbors. And we need to plug those in. And if that works, then we just have to do it for the other directions as well. So let's see if that then... Nope, that fills every tile with the exact opposite of what I'm looking for. Okay. So right now, I'm checking forward and left. So if this corner is empty, it's spawning something. Forward and left. So that means I don't want to check floor tiles. I want to check walls, maybe? So let's change that from floor tiles to get walls, get no. No, anywho, screw it. We're gonna have extra mesh out there. Fine. Since it's in instant static mesh, it doesn't take a lot to draw anyway, so yeah, we're just gonna have it like that. So we have the round corners. Now on these inner corners, where they intersect like that, we need to get my other corner piece. We're gonna copy our spawn outer corners, Control C. Actually, no, we're gonna copy walls. Doesn't matter. I'll copy walls. It's just changing values either way, right? And then we're gonna add onto our sequence. And we're gonna pull on down here. And pull that up there. Beautiful. And then we want to copy our outer corners, duplicate, and call this one inner corners. Okay. And then gonna go, oh, and change that to the other corner type. Then gonna go back to our spawn tiles, inner corners, plug that in there. And then let's see what directions we need. So inner corners, we want forward, right, left, and back, yes. But what we want to do is hands. So forward and right. Right and back. Back and left. And finally, forward and left. Spawns corners. We're going to see if that's in the right direction or whether I need to flip my mesh again. I think I'll have to flip my mesh. Oh, now it's spawning everywhere. Is in array, so that and that are in the array, not. So we don't want those two in the array together. And that's plugged in. Yeah. Floor. Oh. Both of those do exist? No, I think that's just going to give us a bunch. Yeah, that's just going to give us them everywhere. Okay, just looking back at my other stuff here. So I want forward and right contained in floor tiles are not, and add the tile. That should do it. That tile, forward of it and right are in it. Yes, and then if it was an, then we'd want, if both of them are in it, it goes false. Yeah. Don't know why that's happening. Because yeah, it's spawning everywhere. It doesn't do that on mine. But yeah, it's just supposed to spawn in corners like that. Whereas checking forward and left are not, it should spawn there. But here, it would be checking forward and right, has it, forward and left. One of them is there, so it shouldn't spawn. Well, there's your homework. This is where I'm going to end it. If you can figure that one out, why that's happening, let me know. And we'll see you next time when we fix that and we do corridors. And then also add doors to this mess. Yeah. That's it for now. We'll come back, we'll fix that next time. And we'll have, ooh, that was my elbow. And we'll have corridors being built. Yeah. That's it for now. And, ooh, I've been staring at this for way too long now, because it's been like 3 days straight building this and now rebuilding it for a tutorial. I may give it a day or two before doing the corridors.